you need to work hard. If you want to try something new, because probably it won't work at the first time, it won't work the first months. It will maybe take 1 or 2 years before you get it to work. It will take time, so you need to be ready for that. Don't count the hours you will spend in the lab, because most of the things I've done in testing new technology was done in what we call here in Denmark interest hours.
Welcome back to part 2 with Jarno Robin from Sani Membranes. If part 1 got you thinking about continuous bioprocessing, you are in for a treat. We're diving into the technical nitty-gritty with someone who has mastered ATF implementation across 2 decades. Now we'll explore Sani's patented Vibro Membrane Filtration technology, the revolutionary membrane filtration that creates turbulence by vibrating membranes instead of fast cross-flow, which delivers uniform transmembrane pressure and better separations. From scaling challenges to game-changing innovation, let's continue. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Let's assume that I'm listening to this episode and I think, well, this is a great technology to try, but I have my perfusion process running using an ATF. It works well. How easy will it be to change to use this vibrating membrane filtration technology? And what are the potential challenges you're still seeing at the current development stage you're at?
Compared with the ATFs, the beauty of the ATF, you only one connection to your bioreactor. So this Vibro technology, I call it VMF, Vibro Membrane Filtration. The VMF need 2 connections like the TFF. One to get the cells out and then get the cells back in the reactor. If you want to move from the ATF to our system, then you need to have a look to the number of connections you have on the bioreactor, because we need more. But then the potential with this technology, the biggest ATF you have on the market is the ATF10 with 11 square meter hollow fiber. With our technology, we have the 10 square meter, not launched yet, gamma radiated, but we have it. We did the test and everything, passed everything. We just got Lucifer Expressibles data recently. But then our plan is to move to the 40 square meter, because we know how to do a normal classical 40, 80 square meter on the platform. We have 4 tower of 10 or 20 square meters, so we know how to do it. So we know how to do it in a gamma setup. And then instead of having multiple ATF on your bioreactor, 3 or 4 ATF for 40 square meter, then you need 4 connections for your ATF in total. With our system, if we can make this 40 to run, you need only 2 connections. So basically, if you have multiple ATF in your facility, then you don't need to change your facility. And then you can switch off your compressed air and vacuum, because for the vibration, just plug it in and it vibrates. So I will say to move from ATF or a TFF to the VMF, our system, is pretty straightforward.
And now talking about applications beyond biologics or classical perfusion or classical downstream for TFF, for instance. Well, you mentioned algae, you mentioned RNA. What other potential applications do you see, like biomaterials or a lot more?
Monoclonal antibodies from fed batch. Some people using 10, 15 cubic bioreactor. That's something we can handle with the system we have. And the beauty of this technology, you can use 1 unit, so harvest clarification, to remove the cells. Then your product, your antibody, would go through the membrane, and we have above 90% transmission of the product through the membrane. Then you can collect it in a second tank. And then on this second tank, you can add a second unit with a UF membrane for antibodies, typical 30 to 50 kilodalton membrane, and use a permeate, so you can concentrate your antibody in the second tank And the permeate, which is API-free without any antibodies, you can get it back in your bioreactor to wash out. So you don't need water to wash out your bioreactor. You can use this permeate for the second unit in a closed loop. So you can really control the volume of your harvest. And the beauty of this, you start to remove some HCPs or impurities before you go to the protein A column. So you can already do something new and improve the yield and probably protect your protein A column that are pretty expensive. So basically, if you can run 10 cycles more, that's a huge saving also. So this classical process, really data looks very good. So monoclonal antibodies, we have also in the food industry in cultivating meat area where you want to up-concentrate the cells as much, remove some water as much as you can. We have done some tests and we can go up to 15, 17% of drier biomass. So that's pretty high compared to any other systems. And again, doesn't destroy the cells.
And what about the robustness? Because, well, that's a big advantage of ATF now. We're running perfusion processes for many, many days, weeks. Is that similar with this technology?
The motor generating the vibration are coming from the mine industry. So they are extremely robust. They don't break. So far, we had only one and we get it here when we did the test. So it never went to the customer. And we have system now on the market in many years now, and they don't break down. Then when you use it as a TFF, non-sterile applications, you can run a classical CIP and you can reuse the membrane during 1 to 2 years. So very robust, extremely robust. So basically it's good for the customer. It's not good for us because they can keep the membranes for 1 to 2 years. But that's very robust. But again, on the sustainability, it's very good because you can keep the same system in so long time. So you reduce the waste. Then the feedback we have from customers also when they run the CIP is going faster. And they use less chemicals compared to other systems. Again, time is money, but then less chemicals, it's good for the environment. So the environmental footprint of the system is very good. The VMF, it's a new technology, but it's very attractive on the sustainability aspect.
And how do you clean it between two batches? Do you have a cleaning procedure or how do...
Classical CIP base, and the beauty of the system, since it's much more open to compare to any other system, you can drain it. You can empty it. So basically, when you start your CIP, you don't need to spend your first time of your CIP flushing with water to get everything out and then run your base or acid and everything. You can empty the system and run almost directly with base. So, and that's the feedback we have from customers. So it's pretty efficient, much more efficient compared to other systems.
Now, with this new technology and also other developments in the continuous processing, what is your vision for the future? Let's say in 5 years from now, how do you think are we going to produce various biomolecules?
I will hope that we'll move more and more to continuous processing. I know that the batch culture is still there. You have huge facilities worldwide with big bioreactor. So if you have a 10,000 liter or 15,000 liter, I will say you can run with perfusion or ATF or whatever, but then the issue will be the water consumption. So basically, those companies will probably stick to fed batch. But I would love to see more and more continuous processing because to me, it's the best way running a process. But I understand the challenging implementing continuous processing, and it also depends on your business, depends on the product, it depends on the added value product, it depends on your existing facility. I mean, there is no golden rules to figure out run perfusion or batch-wise, but I hope that we'll see more and more continuous because it's smaller size, then higher intensity, higher concentration and everything. So I would love to see more. It's a small community running continuous. You like it or not? So.
Jarno, what is your advice to a scientist who is now developing a process? They decided to move forward with perfusion, and now they're thinking, should we go with the ATF or should we use this new technology? Can you help them, guide them a bit? In what case would it make sense to use the membrane technology, and in what cases would you still advise to use the ATF?
For perfusion, we are moving into this area. So the ATF is still stronger as it is. They have well established now in, above 20 years now, I will say. So they are very strong. Even if you have the challenge, you still get higher yield. So people are still happy, even with the TFF, with both technology. So when you arrive with something new, that's challenging. And that's why I'm now spending a lot of time on getting data to see if I can convince them. It's challenging because pharma, you think about patients. You want to deliver continuously to your patient a nice quality. Introducing new technology is a challenge. And that's what I experienced myself. Basically, if I was in this company, there was not this project having this issue in phase 3. I think it would have taken 10 years more to implement the ATF in this company. So I understand perfectly that even if you come and say that's the most beautiful technology, yield, blah, 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 and sustainability are the best, everything, still, you need to get the people to change, to make the move. I would say best advice is resilience. Try something new, be open, use the vendor, use me, use us to guide you how to use the system to help you to do it faster, not spending too much hours, and see the results at the end. Because articles are good, but generate your own data. That's the most valuable data you can get. Another challenge in 5 years from now, I hope will be like ATF was in early 2000, because I see the potential of it. And it's not only for the upstream, but also for the downstream. So the potential is pretty big, but you need to find the sponsor. You need to find the ambassador in each company.
Jarno, you have been at the forefront of innovation for many years, or shall I say decades, and you have believed in new technologies before a lot of other people have believed in. What would you advise us scientists to? Is there like a number one success principle or thought or whatever you could advise us to also just try and fail and push us as much as we can?
You need to work hard. If you want to try something new, because probably it won't work at the first time, it won't work the first months. It will maybe take 1 or 2 years before you get it to work. It will take time, so you need to be ready for that. Don't count the hours you will spend in the lab, because most of the things I've done in testing new technology was done in what we call here in Denmark interest hours. So you work during the day on your project to deliver for the company and everything. When you're at 4, 5 o'clock in the afternoon, a lot of people are going home, which is good. But then maybe you need to spend 1 or 2 hours more to try something new, because then it's not interest hours. So basically, another way you can start to generate some data, and then it's a snowball effect. When you start to generate data, people, oh, that's interesting. And then suddenly you can get some allocation to spend more time on that. And that's both for filtration system, that's for PAT, Raman, or things like that, other technologies, automating system. It will almost never work for the first time. So you need to spend hours on that. So be flexible on your working hours. I know I've been manager, so it's not what manager want to hear, but that's the way it's working.
Well,
it's just because now in R&D, people are more and more pushed by the time. It's a matter of speed. So you don't have that much time. Before, for 20 years ago, getting old now, you had 10 to 20% of your allocation on new technologies. That's not the case today anymore. It's a speed, especially in R&D, CMC organizations. Now I see more people in MSAT functions having time to have a look to new technologies and implement technology also in production, just because the product is already on the market, and then you can increase the yield. So now it's more and more in MSAT functions when you can implement new technology, try something new.
Well, I love that. Thank you for sharing your advice and your thought. This has been great, Jarno. I love the conversation we had. With all that we discussed today, what is your most important takeaway you want us to walk away with?
Believe in what you think. If you think something is good to test, believe in it and do the job. And resilience and timing, as I said before. That will be the most important take-home message, I will say.
Excellent. This is great. Jarno, where can people connect with you?
On LinkedIn, of course, Jarno Robin. Jarno is not a very famous name, and then Robin very easy to remember. And then also, if you go on the Sani Membranes website, ask for Jarno, then that would be very easy to get in contact with me.
Excellent. I'm leaving all the information in the show notes. And Jarno, once again, thank you very much for sharing your insights, your passion. I very much enjoyed our conversation today.
Yeah, me too, David. That was very nice. Thank you very much.
Great insights from Jarno Robin on the future of continuous processing and Vibro membrane technology. From uniform transmembrane pressure to sustainability considerations, we have covered game-changing innovations. Remember, implementing these technologies doesn't have to be overwhelming. Do you need guidance on your continuous processing journey? Well, schedule a free consultation at brühlmannconsulting.com. Let's make bioprocessing smart together. And thank you so much for tuning in. If you have time, please leave a review, and I'll see you next time. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.